So good morning, thank you very much for coming. And it's my pleasure to introduce to you Dr. Martin Saraceno. He is a scientist at the University of Buenos Aires. He is here on his way back to Argentina from the Ocean Sciences meeting, where some of you are there, and you also have the opportunity to meet again with him. And so Martin has been a long time collaborator with several of you here in the division on studies in the Southwestern Atlantic Ocean. And this is what this talk is going to be about. Before going to the University of Buenos Aires, he obtained his PhD at the University of Paris. You work with Christine?
In Paris, yes.
With Christine. And so it's a pleasure to have him here. For the rest of the scientists, always remember that there are opportunities for you to invite guest scientists in the division. So it's an example. Thank you very much. That's the title of his talk, and it's all yours. Thank you.
So it's already okay. So thank you, Gustavo, for inviting me, and it's my pleasure to be here. And thank you for all of you for coming. And yeah, just before I forgot, I will be here until the end of the week. So if any of you is interested, but some of these subjects or have other questions about Argentina, for example, you're welcome to arrange with Gustavo and meet me anytime. So the title of my talk is Seasonal and Interannual Variability of the Brazil-Malvinas Front. And I added an altimetry perspective, but there is a lot of in situ data and also something that we gain from models. This work turned out to be something that I have been thinking on from several years, and finally, when you have time in those spare times during crisis, a scientific crisis, that is in this opportunity I did invited by José Luis Pellegrí, which is at in Barcelona, with Daniel Falla, and also with inputs from Alberto. Well, it finally came this work out that I hope to submit soon. So the talk essentially will be centered on the result that I will show you right away. It will be a short introduction, and then a kind of validation of the satellite altimetry data in the region with the data that we obtained with the vessel. We present results and a short discussion. And I hope to have time also to show you bonus tracks. That means one more result that we obtained in the region that I think you may be interested on. And the first result that we obtained with a quite large in situ array experiment that we did in the region. So these are not real results yet, but just to let you know what we are doing there. So for those of you that don't know or are not too familiar with the region, the Brazil-Malvinas confluence region is characterized by very large thermal gradients. You have more than 1 degree Celsius per kilometer, thanks to the confluence of the Malvinas current from the south and the Brazil current from the north. So there is a lot of mesoscale and sub-mesoscale features that are happening there in the region. And there is a lot of variety of physical phenomena that is happening there, from south fingers to, as I say, sub-mesoscale and large mesoscale features. This is the origin of the encounter of the two currents. Makes that the region is one of the largest eddy kinetic energy in the world. This is estimated from satellite altimetry data. And well, as you can see, it's comparable or large among the largest eddy kinetic energies of the western boundary currents in the ocean. So this large mesoscale activity in particular produce a lot of eddies, and here I'm presenting results from a work of one of my students in Argentina that just composite all the eddies and composite the fluxes, heat fluxes on the cyclonic, anticyclonic eddies, and she shows that there are a large impact on the air surface over the region. So this is quite interesting, and it's not the subject of this talk, but just to show you that it has the eddy mesoscale activity in the region has the potential to regulate regional climate there. As many of you know, in this part of the world is very interesting from the physical point of view, and it has is the encounter of several water masses that contribute to the thermoline circulation in the South Atlantic. So many of you participate very actively in the South Atlantic meridional overturning circulation, and having great results to understand that this key issue for the climate. Is also a region where the primary productivity is among the largest in the Southern Ocean, and I love this particular picture because it shows very clearly this is seaweed chlorophyll image, so chlorophyll concentration of chlorophyll A, and it shows very clearly how all along the shelf-breed front we have this is average for summer, and we have a very large concentration, and how thanks to the collision of the two currents there is a lot of exportation of this primary activity. So there is some, we know a little bit about that, but I think there is more that we don't know than what we know about the key issues that regulate this particular distribution of chlorophyll. And in particular, if we look at an Hofmöller diagram across the region where the Brazil and Malvinas current collide, you can see in the next slide that in the top panel is SST, and here is chlorophyll A. And this is just between July 2002 and July 2004, so it's a zoom of you can make a longest time series, but you will obtain more or less the same result. And well, you can clearly see the contrast in temperature and the seasonality of the front in the region, but you can also see that there is all along the front, the dotted lines are just the same that is marked here and it's reported here, and all along the front you can see that there is a large concentration of chlorophyll all the year round. So we know that fronts have this effect, but it's nicely shown here. Here I'm showing just to put an accent that if you read in the literature several times we refer to the Brazil front, and it's not exactly the same thing as the Brazil Malvinas front as I will be talking in this talk. So, in several papers, some of the authors are here in the room. The definition of the Brazil front or the subtropical front is the latitude where the Brazil current separates from the shelf break. The Brazil Malvinas front that I will be referring to is essentially the position where really the strongest gradient between the Malvinas and the Brazil current is. And this is one more slide, and I think it's the last for the presentation, showing that the mesoscale activity that generates from the encounter of the currents may have a strong effect on the Malvinas current. And this is a snapshot of January 22 to 6 in maps of the layer topography with the dynamic topography, I'm sorry. And this is of sea surface temperature, and so you can see here a large anticyclonic that was generated at the confluence, and you can see that it's blocking the Malvinas current. So if you measure in this section here the Malvinas current, as was measured 2 times with current meters during more than a year, and then you overlap that time series with the altimetry, you should be very careful that there is a lot of signal that correspond, in fact, at this situation where mesoscale activity is blocking the Malvinas current and is not variability to the Malvinas current per se, I would say. So this is just a composite of all, the maximum situation of the Malvinas current and of the minimum situation. So these are published results. And so now let's go to the result I really wish to present you here, and something that I'm working on, so your comments will be very welcome. And as I say, was the opportunity, it's a work that arises from those spare time that sometimes you have on the vessels when you are doing a large trajectory. In this case, was from 8 to 23 March on 2015 that we left with the Spain hydrographic vessel Hesperides. We left from Ushuaia and we went up to Santos in Brazil. So it was quite a large transit, but we did like 2 weeks work very actively here in the region. And the data that I used for this work was the vessel mounted ADCP, and here I'm comparing the U component and the V component with the altimetry derived geostrophic velocity. So you can see that there is a very nice matchup. This is in purpose, I do not edit it that much, the ADCP data, and after the talk we can talk. If you are interested, we can discuss and I can explain to you what level of ADCP I used, etc. So you can see some spikes, but the correspondence is very good and the correlation is above 0.9 at a 95% confidence level. And we also look at the moments where there are largest difference. Here, I'm sorry, I forgot to put the units. This is meter per second. So you can see that there are very narrow and strong currents that the altimeter is not able to measure. So that's the reason why you have those difference in that moment. If you do some statistic with all those data, so this is the data collected just for the U component from the vessel with the ADCP data, and here with altimetry, well, you can see that the correlation is very good. So what I did next is to make just a comparison between the satellite altimetry and the SST gradient data. So this, I think, was my first publication several years ago in an international journal, and showing the SST gradient, right, with a composite of SST image actually retrieved in collaboration between Erasmus and Argentina. And this is the color code, okay? This is degrees Celsius per kilometer. And in top of that, you have the mean dynamic topography constructed with altimetry and grace and several data. So you can see that there is a really nice matchup on this region where there is very strong gradient both in the mean dynamic topography and with the SST gradient. So that's a nice indicator with a couple of data set that one is 9 years old, 9 years long, this is Spanish, and with altimetry more than 20 years. And the two data set, this is interesting, they match up just for some years. So if we look, I will display a time series along this section. And again, as I show you the of Moller for the chlorophyll, But now what I did is, again, here the temperature product, and here the SST gradient along that section. And this time I will just take one contour of absolute dynamic topography from altimetry. And you can see that correspond very well with the front. So this is the main message of the talk. So there is a particular contour, a similar approach I have been seeing in the ocean science for the Gulf Stream region, and is published also in the Antarctic circumpolar current on the northern part on the Drake Passage has been doing to study fronts. So you can find a particular contour that here in the region represent very accurately the Brazil-Malvinas confluence front. So that we can use it to composite now and make averages of the different seasons. And what you can see is that the front actually change, the northernmost position changed from summer to winter, quite large. But essentially it pivots from a more north-south position to a more diagonal position here, northwest to the south east, and here's a fixed point. This is the result that was published in 2004, and altimetry reproduced it very well. So those are the positions from the paper on 2004. And that here is represented again. So this is the SST gradient from the paper on 2004, so where you can see the maximum gradient in this direction, and here in winter more north and south, exactly as I explained before. So now I try to find a correspondence between the currents and the position of the front. So what I did is estimate averages of geostrophic currents at in the Brazil current and along the Malvinas current. And I explicitly take a position farther south, not where we have been measuring at 41 degrees south, because we know that here we have a lot of mesoscale that can be contaminated in the signal, and it is more difficult to make the interpretation. So if you do that, well, for the Brazil current, we have that a nice seasonality, which was also reported during the meeting by Claudia Schmidt, and even if with us, well, she estimated transport, I don't want to estimate transport because I only use geostrophic currents, and that the current is very baroclinic there. And at 45 south also you have some seasonality, so it's stronger in winter and a little bit smaller in summer, but is if you look carefully at the units, it's the Malvinas current is always larger than the Brazil current. So a cartoon for this will be here the arrows are proportional to the intensity of the currents. So that's why this arrow is wider than the Brazil current. The Malvinas current is always larger than the Brazil current, and that explains why the Brazil Malvinas front is at that latitude. Otherwise, that's published many years ago. The zero wind stress score determined that the Brazil current, which is the boundary current in the South Atlantic, should be much southern. So the Malvinas current, we know, is the responsibility for having the separation of the Brazil current farther north. And these results suggest that indeed we have in winter larger currents for the Malvinas current, and in summer relatively stronger Brazil current than the Malvinas current. So this explains why in summer the position of the front is towards the south, and in winter it's more probable to have it northern. If we just take the latitude of the northern position of the front, and this time we average year by year the fronts, this is the result that I obtained. So this is 1993, from blue to red to 2014. So you can clearly see that this is a migration of the front from an interannual point of view. So if you plot just that latitude, the northernmost, you can see well that there is interannual variability, but it is clear that I just took here a standard deviation for this period of time and for this period of time, and there is at least 1 degree southward migration during the altimetry time period. And this is coincident with results of Gustavo et al. So, final remarks. Sea surface height estimated by satellite altimetry in the Brazil Malvinas Conference region shows a strong correlation with in situ data and other satellite data I've been showing here. Using a VISO gridded data, that's altimetry data, the 0.03 meters contour represent very accurately the position of the front in the region. And we also show that there is a nice match-up with previous results that shows a seasonal migration of the orientation of the front, and that there is an interannual trend to the south. That means that at least the front migrated to the south 1 degree in the last 20 years. Already I said that. Okay, I also say that. So now I still have 10 minutes that I wish to spend in this 2 bonus track. I hope you are still awake to listen to them. And so these are results that published almost 2 years ago now. We are on 2016 already. And is always using satellite altimetry data to show how they are useful to study the Rio de la Plata plume. So we are always on the southwestern Atlantic Ocean, and the first thing that we computed was the linear trend. Okay, I should say that before this work we published a work showing a precise comparison of all the tide gauge available in the region with the altimetry data, showing that at seasonal and for interannual studies the altimetry data are quite good in the region. And so here we computed the linear trend, and well, you can see that the pattern is quite complex. There are some points with negative values, but the dots indicate that they are not significant, those values. And you have larger values in this region. And we try to explain that, and we show that as a matter of fact, the wind, using Quiscat wind from the northeast in this region is larger, increased in the last years, and so this is a kind of acceleration of the wind stress. So that could be a reason why there is an increase in sea surface height in that region, close to the coast. The larger values that you have here are related with the Brazil Malvinas front, and was the subject of the previous talk. So we also compute here the EOF of the seasonal cycle. So we computed the seasonal cycle, and then we estimate the EOF. So here representing the first mode that explains the largest portion of the variance, but because we used just the seasonal cycle. So you can see a pattern that this pattern, I mean, which is, remember that we are in the southern hemisphere, so we have maximum values on summer and minimum values in beginning of winter, autumn, and this pattern is explaining very well all this region, not this one. Okay, so this this seasonal cycle, remember as the seasonal cycle of the annual surface heating, so it's essentially the steric heating, and the spatial pattern of the from SST is interesting, that is very high here and not that much in this region. So there is some other mechanism that should explain the pattern close to the Uruguay and southern Brazil coast. And in fact, if we look at the second mode, that explains 33% of the seasonal cycle. It's complementary to the first one. And now the signal is has a maximum in winter and minimum in summer, and this corresponds to the seasonal cycle of the wind in that region, that essentially push waters towards this region in winter, and it reverses in summer. So to check that variability, because we always have reviewers that do not trust that much the altimetry data, we did the same computation with some nice tide gauges that we have in the region. As a matter of fact, the tide gauges in Buenos Aires at Palermo station is among the 3 or 4 in the world in terms of quality and longest time series. So this is one of the tide gauges we used, and this this plot, I love it. It shows that just no AOF, just the composite, the climatology for January and July. So this is altimetry, and you can see that there is a clear pattern, right, as shown with the AOF. So here you have blue values, and in winter, largest values here. So there is a dipole pattern here in the Rio de la Plata region, and the tide gauges show you that as well. So this is time, and this is sea level anomaly, and these are the tide gauges, right? And one is the orange one is here in Buenos Aires, and the green one is at La Paloma. So it shows like that there is a shift in time, which explain this above 20 centimeter difference that we have between summer and winter. So conclusion is that the sea level trend is about 5 millimeters per year in the region, a little bit less than that, and which is in agreement with it's not in all the region, but there is a region where it is as high as 5 millimeters per year, which is quite large value compared to worldwide sea level trend. And that sea surface high annual component is dominated by the annual component of the temperature, I mean steric height in the Rio de la Plata region, and the wind along the coast of Uruguay and South Brazil explain the variability in that region. So, second bonus track, that's very good, we are on time. And it's some efforts we are doing, thanks that our lab in Argentina is an international mixed unit to climate studies, so that we can apply not only to funding from Argentina, but also from Europe. And so it's international, in this case with France. And in that way we obtained a project to put 8 moorings along this Topex Poseidon track for a year. And then the idea is to recover them, we already did it, and redeploy it here at southern transaction. So the objective of the work are not only to compare with altimetry data, but also to check some results that our modeler colleagues were suggesting, and they were evident also from some other in situ measures. That, one of them is that the circulation on the Patagonian continental shelf is dependent on the Malvinas current. So it's not only to measure, to obtain for the first time on the continental shelf long time series of currents, but from in situ data, but also to check the relationship between the Malvinas current and the circulation on the continental shelf. So the instrument that we deployed, essentially this is a tall mooring with current meters and buoyancy, acoustic releasers. So those, we deployed 3 of those along the Malvinas currents. And then we deployed in 4 of these cages. Sorry, this is French, with acoustic Doppler profilers and CTs, and in some cases also bottom pressure recorder. So we deployed 1 here at 1,000-meter depth, and other 3 along the over the continental shelf. So, and there was also 1 full buoy oceanographic mooring with a surface unit with meteorological data, and a lot of CTs on the subsurface. So this is very nice, but as always happened, this region, because of this very large primary productivity, is subject to a very active pressure by fisheries. And in fact, one of our cages was coated a month after deployment, and the buoy with the surface unit was hit by one of the vessels. If you look at night image, it's amazing. You can see here that you have more lights than in Buenos Aires, the intensity of lights. So it's not, it's really, and when you sail over there, you can see fisher vessels everywhere, so you should be very careful. But the other 5 moorings were successfully recovered. And well, deployment of moorings in Argentina is not very easy, not always easy. So you can see here our oceanographic vessel that was not working just before leaving, and so there was another vessel which is just a yeah, how do we say in English, a supply? Yeah. This was a supply. So we did the deployment with the supply instead with the oceanographic vessel, but we can do it and we could recover them. So some nice pictures of the deployment and of the recovery, and some results also. And that's my last slide. This is from the pressure recorder on the 1,000-meter depth, and this is pressure. And well, there is a small trend that for bottom pressure recorder is normal. This is a year-long time series. And well, this is a zoom, and you can see that there is not only a tide, but there is an envelope here that might be suggesting that the presence of internal waste, that is something that has been proposed as an explanation for the large primary productivity in the region since a long time ago. So with that, I end my presentation, and I thank you for your attention.
Sorry, what was that last ship? The picture of the last ship. Sorry,
yes.
What ship was it?
Oh, that was from Prefectura Naval, from
Coast Guard.
Coast Guard, yeah. Was
It's the Tango.
Tango.
Tango, yeah.
Okay.
The small one here, yes. Renelis?
Very good talk. I really enjoyed it. I was wondering if the relationship that you found was very good between the 0.3 meters sea surface height contour and the gradient of temperature. When you showed it was quite good for 5 years, but as we know in the region, the sea level is increasing. And do you think over the 20-year altimetry record, that relationship is degrading on longer time scales?
Yeah, and I mean, I did the Hofmöller for the complete time series, and compare it to SST gradient is still a very good indicator. I mean, that's why I use it also to show the interannual variability. Both in SST gradient and in wind, the work that in 2011 published Gustavo showed that there is such a nice result. Yes, please. Hi.
When you studied the seasonal cycle around the coast with
Mhm.
the time gauge and altimetry, did you use the normal gradient aviso altimetry data? Did you do specific treatment? Because it's on the shelf, and usually altimetry measures on the shelf are more.
Yeah.
Did you use the basic products, or did you have to use specific treatment?
For this publication, we used the standard product, and thank you for the question. And once again, is because we look at only at the seasonal cycle or yearly average to study trends, etc. So if you're looking to lower time scales, you should be very careful. In fact, one of my students, that she finished her PhD now, but she's showing that there are, for the to have nice altimetry data, you should do a lot of corrections. So there are several of those corrections that, in particular in the Rio de la Plata estuary, they are not accurate. So, but when you make seasonal studies, there is no bias that is introduced in the results. Yes, please.
There is no problem with shallow water tides in that region?
We haven't looked in particular to shallow water tides, but we do show that when we're looking at the total water level as estimated from the altimeter, that is without the corrections, you can see very well that the altimeter is working properly, and you can detect storm surges and other short frequency phenomena. So yeah, and this is a subject of my PhD student. Message is altimeter is working properly, but we don't know very good the correction that you should apply, the dynamics that we need to subtract to the altimeter data because of his frequency and space sampling. So that's the message.
When you shoot the figure with the variation of transports of the Brazil current and Malvinas currents and where the front is, where is the wind stress curve here? That probably has something to do.
Yeah, actually, this is the cartoon from the result of the previous slide where the average of the geostrophic currents is made. I'm not talking about transport because we don't measure it yet, at least in the Brazil current. In the Malvinas current, we don't have a good idea. We know that it's barotropic or barotropic equivalent, but we haven't measured yet, so that we can measure transport with more confidence. But your question is about how the winter enters in this cartoon?
No, the wind.
The wind stress. I'm sorry.
Yes, if it changes, part of that change that you have there, a seasonal change, or the change that went from 93 to 2014, any of those changes are related to changes in the wind stress curve.
Yes, the interannual variability, as you show in the paper, and also it's I mean, you just need to take data and show that there is a trend on the South Atlantic low pressure system that is migrating to the south and that is increasing wind stress, and that's probably the reason for the migration to the south from an interannual point of view. But then the seasonal behavior of the front here in this region, well, this is not proving anything, but is at least suggesting that in winter, the strongest current of the Malvinas current as compared to the Brazil currents are pushing the front more to the north. And in summer, the opposite happens. Okay, it's an imbalance between the two currents that it makes this determines the position of the Brazil Malvinas front.
Sorry, but then you didn't mention that, but I'm curious about. You have this fantastic array of chronometers across the Malvinas. What numbers do you get for the transports there?
I'm sorry?
The transport of the Malvinas current. Do you have a number for there?
Yeah, we recovered them with the great help of Raúl end of November last year. So we are still, and unfortunately the one of the moorings, all the instruments were ruined. So yeah, they were all under and they all get water. So we only have measure from 2 current meters. With that were yeah, sure.
So
yes, please.
Can you comment on the mechanism of the south shift of the front is related to gyre scale dynamics or the volume of the entire subtropical gyre in the South Atlantic?
I will say that the general picture is that the separation of the Brazil currents do not respond in this region to the zero wind stress core as in other Western current system, right? And these, well, are papers that have now more than 20 years, I think, and it's because of the Malvinas currents. So the Malvinas currents, if you do just an analytical model, you can show that work both at the same time in 1993, if I'm not wrong. Doron Noff and Ricardo Montano published results suggesting that. And so that's the reason of, but then there is a discussion about the seasonality of the front. Okay, and well, here I'm suggesting my point of view or the altimetry point of view about the position of the collision front, that you should not confundir, you should not exactly with the position of the separation of the Brazil current, right? That is more often discussed in the literature. Does that answer your question? Or partial? Yeah, the second part I don't know. I don't know the answer. Bueno, gracias.